Hi students, this is the first lecture of the capital budgeting techniques. We will be discussing in this course that how capital budgeting can be utilized in order to selecting a project. Why we can call it as a capital budgeting technique? Because you have a capital and you have a budget. So the capital budgeting means that the capital that you can spend in a way so it can benefit you over the number of years. Because if you put money today, you will be getting cash flow in future point of time. So my question is that by standing today, if you invest for 1 to 5 years, 10 years, then the investment that you have in long term, whether it would be beneficial or not. So this capital budgeting techniques will give you a glimpse to understand that how this can be beneficial for understanding that whether you need to put this money in this project or not. So in order to understand this, the first is the we have the capital budgeting techniques we are discussing because we can evaluate the project and we can select the project so we can find out that whether we will be able to identify that whether we need to invest money or not. Potential difficulties. So every method has its own pros and cons, so we can find out. So capital rationing means that the capital that you have, and it makes some kind of sense that you will be getting profit or not. So the money that you will be spending is actually having some its own significance or not by putting money into the projects. So project can be monitored and post completion audit can be possible if you look at this capital budgeting techniques. See, these are the few topics the capital budgeting we'll be discussing in the next slides. So these are the total techniques, 4 techniques that we need to study under this chapter. The first is the payback period. I'm just trying to provide a glimpse so you can understand. And then these are all the mathematical expressions so we can find out and how we can calculate these and can find out whether the project that we need to invest money, whether it would be beneficial or not. So first method is a payback period, which identifies ensure that if you put money, so in how long it can take that you can recover your initial investment, the investment that you can make today. So in how many years you will be able to recover, that is known as a payback period. Whereas internal rate of return means that what would be the return that we will be getting out of the project. So this return should be more than the benchmark return. Suppose if the return we assume here that the return should be 15%, it cannot be less than 15%. But if we find out the internal rate of return of our project, and if it is less than 15%, the project cannot be accepted because the desired rate of return is not achievable. So or alternatively, if the return is more than the 15%, then the project is feasible. We need to invest money. The return is more than the return that we actually expecting. The next point is the net present value, and these IRR and NPV both are commonly used method in determining the significance of the project. So NPV means that the discounted cash flows, the value of discounted cash flows minus the initial investment. So if the answer is positive or if the answer is in zero, the project can be acceptable. But if a single rupee, if it is a negative -1, -5, -500,000, -10,000, then the project has to decline because the money that we'll be getting in future, its value is not equal to the amount of money that you need to spend today. And the last point is the profitability index, which actually is equal to the discounted value of cash flow divided by initial investment. I repeat, profitability index is equal to discounted value of cash flows divided by initial investment. If we divide, the answer can be more than 1. The answer can be less than 1. If the answer is 1, it means that all the values, discounted value of future cash flows is equal to the amount of initial investment. That can be a break-even point. But if the answer is more than 1, that is 1.10, it means 1 is the original amount of investment that you have, and my 0.10 is 10% return out of the project. And if the answer is 0.92, it means that there is a loss, 1 minus 0.0. So you are actually making a loss of 8% of the out of the project. So I will go and I will see step by step then how we can calculate this payback period. So I start with the payback period, and payback period in simple word, it means that uh, in how many years you will be able to recover your initial investment. So mathematically, I can explain, I will explain it. And first we need to go for the question. And what is the question? A company is evaluating a new project for their firm. They have determined that the after-tax cash flow for the project will be 10,000, 12,000, 15,000, 10,000, and 7,000 respectively for each of the years 1 to 5. And the initial cash outlay will be 40,000. The amount of money that you need to invest today is 40,000. If then you will be getting 10,000 in the first year, 12,000 in the second year, 15,000 in the third year, 10,000 in the fourth year, and then lastly 7,000 you will be getting in fifth year. So now the question is that in how many years we will be able to recover this 40,000 rupees. Now I try to understand. So you can write these values. So I also try to write these values so I can explain on the paper because it is difficult to explain on the slides because it's a mathematical expressions. Here I'm trying to write on one side we have years, 1, 2, 3, 4, and 5. And then I'm writing the cash flow that we will be expecting in the first year, that is 10,000, 12,000, 15,000, 10,000, and then 7,000. So this is the question that we have, and then I can solve this, that how we can solve this payback period. So on one side, I'm writing the years, and on the other hand, I have written the cash flows that we will be expecting in 5 years. But the total investment that we need to spend today, that is in zero, is 40,000 rupees. Now I try to find out that in how many years we will be able to recover 40,000 rupees. So I'm trying to cumulate these cash flows. I'm trying to add 10,000, 12,000, 15,000. I'm trying to add this cash flows every year to cumulate the cumulative cash flow. So I'm trying to write here the cumulative cash flows. Cumulative cash flows. And in first year it is 10,000, so we can write it as, and then we can add 10,000 and 12,000, that makes 22,000. So likewise 22,000 and 15,000 we can add together, gives you 37,000 total cash flows in 3 years. So I'm trying to write is 37,000, 47,000, and 54,000. So I added all the cash flows to find out. So I added all the cash flows to cumulative cash flows. So in total, in second year, total cash flows combining first and second year will be 22,000. In third year, total 3 will be 37,000. Fourth year, 47,000. In fifth year, it's 54,000. By looking at this cumulative cash flows, it can be easy to understand that actually the payback period is falling in between 3 and 4 years, because 37,000 and 47,000, we have to recover this 40,000. So we have to recover this 40,000, and we know that this 40,000 is actually falling in between 3 and 4 years. So it actually falling in 3 and 4 years. So the answer of 40,000 is actually falling in between 3 and 4 years, or it is actually falling in 37,000 and 47,000. That is 40,000 that we have. So it is for sure that payback period is 3 years, and it is more than 3 years. So basically the payback period is 3 point something. And in 3 years, the total cash flows that we have to recover is 37,000. So 3,000 we will be recovering in fourth year. So we can make it that this 3,000 we will be recovering, that can be 0.2, 0.3, 0.4. So we can calculate. So the payback period is equal to 3 years. Payback period is equal to 3 years plus. So we are trying to find out here is the payback period, which is equal to 3 year plus. And we can take it that this is the 37 we have recovered, that is reflecting in 3 years, and 37, 3 years, reflecting 37,000. The rest of the money that we need to collect is 3,000. We can simply write it as 3,000, but we can write it as 40,000 minus 37,000, that is 3 years. So 40,000 in total that we have to recover, but we have recovered in 3 years 37,000. So we can write it as 3 years, the answer, plus 3,000 that we will be recovering in the fourth year. So in total, we have to recover 40,000. We recovered 37,000 divided by the amount of money that we recovered in the fourth year. So we recovered in, that is 10,000. So 3,000 we have to recover, but in total, in the fourth year, we recovered 10,000. So we can take the difference of this is 10,000, but we can take this 10,000 and we will be getting the answer. So we can solve this expression and we will be getting the answer. That is 3.3 years. So that is 3.3 years. So this is the answer that we have. So first we have the cash flows in different years. So we can cumulate the cash flows. So we can find out that this 40,000 is falling in between 2 years. So it's actually falling in between 3 and 4 years. So the answer is actually falling in between 37 and 47,000. So it is for sure that we have 3 years plus the amount of money that we have to recover in the fourth year, that is 3,000 we have to recover. But the amount that we have recovered, total amount, that is 10,000. So 3,000 divided by 10,000 gives you 0.3 years. So the total answer will be 3.3 years. So we will be getting this 3.3 years. So this is the question that we have solved, and hopefully it is understandable that we can recover. So total 3.3 years, we can recover to 40,000 amount of money. So if we have two projects and if we come to compare the projects, so if we will be getting cash flows in a short span of time, then we can find out that this project is feasible. If answer is 3.3 and if the answer is 3.8, so if you want to make a comparison, then the two projects, without considering this factor, what will be the initial investment that you have, what will be the cash flow that you will receive in number of years. So here you're just trying to make a point on the basis of the payback period, and the payback period is the amount of money that you need to recover in a short span of time. So if you have 3.3, 3.8, two projects, you need to select a project in which you will be recovering your initial investment in a short span of time. In a short span of time. So you need to go for the project that have a life of 3.3 years. So here we can find out some slides shows that this is independent project. For this project, assume that it is independent of any other potential project that a Salman or company may undertake. So independent here means that project whose acceptance does not prevent the acceptance of the other project that can be under consideration. We discussed this payback period. We discussed 3.3 years. We discussed 3.3 years. And now the question is that whether we need to select this project or not. Payback period acceptance criterion. This vary from question to question, and this can be given the question if you want to need to identify whether you need to go for this project or not. The management of the company has set a maximum payback period of 3.5 years for the project of this type. Should the project be acceptable? Anything less than 3.5 years is acceptable. But if anything, the answer is more than 3.5 years, the project is not acceptable. So every method that you need to undertake this under this capital budgeting techniques have some strengths, have some weaknesses. Its strength is easy to understand, use and understand, can be used as a measure of liquidity, easier to forecast short-term and long-term flows. Whereas the weaknesses does not account for the time value of money. We are just trying to simply add the cash flows. We are not concerning with this fact that what will be their value in zero today, what will be their value. We are not considering this fact. So this is the major flaw of this model. Does not consider cash flow beyond the payback period. So anything that we'll be getting after payback period is not considered in this method. Cutoff period is subjective, so it's a subjective again because once it cannot be discounted again, it will be a part of the subject. Second is the internal rate of return, and now the question is that ICO. If you look at this formula, before going into the definition, I want to go discuss this model. ICO is the initial capital outlay. This is your initial investment. You have the cash flows. We know we have a cash flows, 5 cash flows over 5 years. We have the cash flows, and we need to find out this IRR. We need to find out. And the question is that again, it's an interpolation. Again, earlier we have identified in the chapter 4 that if we have a bond price of 56 rupees, then what would be the yield of the bond? So we actually calculated. Now in this case, again, we have to go and hit and trial method in order to identify that what would be the value of the cash flow. So my question is that in simple words, so ICO, that is 40,000. If we discount all the values with a specific internal rate of return, the value should be equal to 40,000. So both the values should be equal. So both the values should be equal. I think so that before studying this model, I need to go to NPV. So first I will discuss NPV because there is a reason that's why I'm trying to focus on this NPV first. So this is the formula that we have. And NPV, so first I need to explain this, and then I will go for the internal rate of return because we have to make the formula out of this this NPV. NPV is equal to net present value is equal to discounted value of cash flows. We know the CF cash flows. We know the rate of return, that is K. We know the initial capital outlay, and once we can solve, the answer can be in positive or it can be negative. If the answer is in positive, the project is feasible. We need to go for this project. But if the answer is a negative, we need to decline this proposed project because it actually gives you negative returns, because all the cash flow that you will be receiving in the future, if you discount it today, subtracting your initial investment, the answer is a negative. So it means that the value of the cash flows that you receive in future is less as compared to your investment today. So if we go for this, and I can solve this from the previous question, NPV we need to find out. And here we can make an assumption that the discounted is 13%. So here, on the basis of the previous question that we have, and I'm trying to just to find out that how we can solve this. 10,000, the cash flows that we have, 10,000, 12,000 in the second year, 15,000 in the third year, plus 10,000 in the fourth year, plus 7,000 in the fifth year. So I'm just trying to write the expression that we need to solve. The internal rate of return, the return on the project is 13%, is given the question. So this is the simple expression that we have, and we can solve this with the help of this method. So this is the formula, and I need to put the values in this question. I'm using the similar question that we have used for the payback period. So NPV is equal to 10,000 is the cash flow that we receive in the first year, and so on, the different cash flows. We need to discount it so we can get the today's value, and then we can discount it all the values. We can subtract this value. The answer can be in positive. The answer can be in negative. If the answer is in positive, it means that the project will give you some positive returns, and we need to go for this project because it will give you benefits, because by investing this you will be getting positive returns. So on the basis this is the most popular method of evaluating a project, and on the basis of this we need to decline or we need to accept the project. So if the answer is n positive, we need to go for the project, and we need to. So if you solve this expression, the answer is 1428. So answer is you can write here 1428. So if the answer is in positive, it means that we need to accept this project. So on the basis, we can find out how we can solve this. So I use this formula to get this NPV that is positive 1,428 and 1,428. So the management of the company has determined that the required rate is 13% for this project, and we need to go for this project or not. The answer is no, because the answer is a negative. Sorry, so the answer is a negative. So we have a negative cash flow. I didn't see the exact answer, that is minus. So if the answer is a negative, we need to decline this project because it is actually giving negative returns. So project NPV, so anything in negative, -1, -2, -1,428. So NPV is a negative. This means that the project is reducing shareholders' wealth. So it actually gives not giving you any benefit in long term. So we need to decline this project. So this is the most popular method that we need to follow in order to understand that how we can evaluate the project. So if it also has some strengths and weaknesses. Its cash flow assumed to be reinvested at the hurdle rate. Hurdle rate is the minimum rate in which we need to make investment. So this hurdle rate means that this is the rate of return, basically the rate that we need to get from the project. So every project has its different hurdle rate. So if your answer is more than the hurdle rate, then the project is acceptable. Then if your answer is less than hurdle rate, so it means that the return that we are trying to compute in order to find out this NPV, it is not the case that we will be getting the cash flows. So again, I repeated, cash flows assumed to be reinvested at the hurdle rate. So again, just make an assumption that cash flows are to be reinvested, but here we are just trying to focus, though it's actually a benefit on the part of this NPV. Account for time value of money. Yes, time value of money is accounted for when we discount it. Consider all cash flows. Yes, but it may not include managerial option embedded in the project. So managerial options may have different meaning because it's a subjective matter. But on the basis of the values, we can find out this project is feasible or not. So we need to go for this on the basis of the project. So if you look at this something into the graph, we can find out on one hand we have NPV, on the other hand we have discount rate. So we can find out if the discount is lower, the present value would be high. But if the discount is increasing, the NPV will become zero. So we can find out this, and this is the point that I'm trying to just to point out is that IRR. So IRR, now we need to move on this IRR from this graph. IRR is a rate at which NPV is equal to zero. If you do look at this NPV, where NPV is actually falling less than this 14%. And if you look at this IRR is zero. So NPV, now it is easier to understand and easier to describe that how we can use it. So if you look at this formula, here NPV will become zero. So if NPV will be zero, I'm trying to write here, NPV will become zero, CF 1 plus K power 1, and then CF n 1 plus K power n minus ICO. If you look at this, that if NPV is equal to 0, it actually squeezes the formula. NPV is 0. So we have a discounted cash flow minus ICO. This is NPV, but in IRR is the rate at which NPV is equal to 0. So if it is 0, we can solve this formula. ICO CF1 1 plus K 1, and likewise CFN 1 plus N. So this is the formula that we have. And earlier we have seen this formula, but actually it is actually derived from this NPV. Now I move on to the rest of the slides and find out that how we can get this IRR. So IRR is the discount rate that equates the present value of the future net cash flows from initial investment from an investment project with the project initial cash. In short, IRR is a rate at which NPV is equal to 0. So if you remember the formula of NPV, that is equal to cash flows, discounted value of cash flow minus initial investment. So IRR is a rate at which NPV becomes 0. So if NPV will be 0, then both the sides will be equal. So both sides should be equal. So that's in order to bring both the sides equal, we have to make an assumption that IRR is a rate where NPV is equal to 0. And now we can solve this. And we know that this IRR is being used with the help of the hit and trial method. I will not solve it. I will explain through the slides so we can find out this. So this is the assumption, and I'm trying to put the values. 40,000 is the initial capital outlay. This is your initial investment. Now I'm trying to discount all the cash flows with the IRR, and IRR is a rate. If we solve this value, the entire discounted cash flow will be equal to 40,000. So this is the rate that we have. So we go for the hit and trial method, and we can try it as 10%. And if it is try 10%, the answer will be equal to 41,044. So I know that once we go for the interpolation, one value should be less than 40,000, one value should be more than 40,000 in order to find out the exact IRR. So we are getting this 41444. So if we increase the IR rate, that is 10 to 15% or 20%, the value will be less of this 40,000. So let's try at 15%. If we try it, now the value will be lower than this 40,000, which is equal to 36,841. Now we can put this value into the interpolation, and we know that IRR is a rate where the value of your initial investment is 40,000. So both values should be equal. IRR is a rate once we can compute, and then the answer will be 40,000. So we calculated that if the internal rate of return is 10%, the NPV is 41,444, and if the IRR is 15%, no, sorry, initial in this IRR is a rate where the initial investment is 40,000, but if IRR is 0.1, it means that the value of your initial investment is 41. The value of the is 41,444, and then 15%, then the value will be 36,841. So we can go for the interpolation, and then we discuss this. This is actually 10. IRR is a rate which is actually falling in between 15% and 10%. So from IRR, because the value is increasing from 0.10 to IRR to 0.15. So IRR can be 11%, 12%, anything. So we can take the difference, IRR minus 10%, that is equal to x. And likewise 10 to 15 we have a point. So because we are trying to subtract this from 15 to 10%, that is 0.05 or 5%. But here we are actually subtracting 41 to 40,000, 41,000 to 36,000. So we will be getting, so we can divide x by 0.05, and on the opposite side 1444 divided by 4603 gives you x, that is 1.57. And we know that IRR is x, and if we add this x into 10%, giving you 11.57. So this is the internal rate of return. So this project will give you 11.57% return. So if you look at the criterion, the hurdle rate is 30%. Hurdle rate is a minimum rate. If you want to accept the project, then you need to get this minimum rate of return out of the project. So this hurdle rate is 13%, so minimum rate of return. But the project is acceptable? No, because the project is only giving you 11.57%, which is less than hurdle rate. So project has to decline. So if you look at the strength, based on the time value of money, consider all cash flows, less subjectivity, yes, true. Weaknesses, assume all cash flows reinvested at the IRR, and we are making assumption that the cash flows are not reinvesting. That's why NPV is equal to 0. It's difficult with project ranking and multiple IRR, so it actually creates difficulty with project ranking. And the last method we need to discuss is the profitability index. Earlier I've said that profitability index is equal to discounted value of cash flows divided by initial capital outlay, and the answer can be more than 1, answer can be less than 1. If we divide both these values, and both values are same, the answer will be equal to 1, that is a break-even point. So if we solve this, discounted value of all cash flows divided by future, divided by initial cash flow, that is 0.964. So this project is giving you a loss of 3.36%, because 1 is a break-even. Answer should be 1, that is equal to break-even. If answer is more than 1, the project is profitable. If the answer is less than 1, the project is making a loss. So no, because the PI is less than 1, profitability index less than 1. It is actually same as NPV, allows comparison of different scale project, whereas it weaknesses again provides only relative profitability. It creates ranking problems. But I will go for on the next slides how we can rank different projects. So on the basis of the 4 methods, and this project will give you 3 points. This is a project summary. The project factors that we determined, but comparison means that is a benchmark. And on the basis of the benchmark, the result of the project, we need to identify whether we need to accept or reject the project. Payback period is 3.3, is less than the benchmark, because in 3.3 usually we'll be recovering our initial investment. The project has to acceptable. If IRR is less than the hurdle rate, the project has to reject. NPV, if it is negative, the project has to reject. If PI is less than 1, the project has to reject. So every method has its own pros and cons, so we cannot rely. So these are the summary of all the things that we have. So in the first question that we need to go, and this is the question, this is a self-correction problem first, and I am trying to solve this. We can find out, and we can look at that how we can solve these questions from the point of view of all the methods or anything that can be mentioned in the question. So if you look at the question, the company is considering a new project line to supplement its range line. It is anticipated that the new product line involves cash investment of 70,000 at time T, and then at time T0 and 1 million year 1. So again, investment is not based on the 0, based on the first year. So after tax cash inflow, 250,000 expected in second year, because you are investing in the first year, you are not getting anything in the shape of cash flow. 3,000 in the 3 years, 350 in the fourth year, 4,000 in each year thereafter through 10 years. Though the product line might be viable after 10 years, the company preferred to be conservative and end all calculation at that time. If the required rate of return is 15%, we need to find out NPV, whether it is project is acceptable or we need to decline the project. So in order to solve this, first I will go for number of years. Yes, year 1, 0, 1, 2, 3, 4, and 5 to 10, because from 5 to 10 years, yes, 4 years we will be different cash flows, but thereafter from 5 to 10 years we will be getting 400,000 in every year from 5 to 10 years. So the cash flows that we have, so 7,000 initially we have a cash outflow, we have 1 million, that is a cash outflow. We actually getting cash inflow of 250,000, 300,000, and then 400,000. And now the first point is that we need to go for the rate of return of 15%. So I just summarize the values here, 1 to 5 to 10 years, and then that these values are the same. We will be getting from 5 to 10 years. So these are the cash flows that we have. So we need to discount it, because in the first year we have to again invest in the second year in the first year. So we need to discount it, that what would be valued today. So in 0, what would be their value? Its value is less than 1. So I'm trying to find out the present value, and the present value means that in 0, in everything in 0, the present value, because if we take it as anything x divided by 1 plus I power is 0, that is equal to 1. So in 0, everything will be equal to will be same, because if you have the money in your pocket, it has the same value, because we don't need to discount it, because it's the present value we have. So we go for the 7,000. So this is same for 7,000. It's a bracket. We need to put this bracket here, and then discount rate is 15%. Here we can find out this 870,000, and how is actually coming. I put here. So in the second year, we will be getting this value. So 870,000 we will be getting, because I put this in the bracket because it's a cash outflow that we have in the first year. So their value today is 870,000. So we actually discounted it, and likewise we need to discount it 15% in the second in up to number of years, 197 and 4,000. So if we have, and what would be the method, because here 400,000 from 5 to 10 years the same, we need to go for the NOT formula. So we can find out the value. I'm putting this value here to find out the value. 1 minus 1 plus I. So this is the formula through which we can find out, because we are making assumption for the 10 years. So this is the NOT that we have, but then we multiply this value. So if we solve this, 1 minus 1.15 from 10 years, 0.15 years, that gives you the 5.019. That is 5 point. This is present value annuity factor. We will be getting, if we solve this, is a value But the question is that from 1, 2, 3, 4, 4 years, the value of the 4 years with an assumption that 400,000 will be getting from first 4 years is including this value we need to extract. So we will be getting the discount factor from 5 to 10 years. So I'm trying to find out here minus 1.15 power 4.15. The answer is giving you is 2.855. So this is the value that we have. So this value is based on 1 to 10 years. This value is based on 1 to 4 years. So this value is based on 1 to 5, 1 to 10 years. This value is based on 1 to 4 years. So we can exclude this to get the value of 5 to 10 years. So this value is 2.164. And if you multiply this 865, 600 and 117, 800. So we have subtracted, earlier we had subtracted, and we can find out this NPV is a negative because, so this is the discount factor that we will be getting 2.164. Multiplying with this value, the total answer will become this. And if we add all these values, these are the outflows. These are the initial investment. This is the investment that we made in the first year. So we actually, the cash is going out of the company. So we can combine together, we will be getting NPV. If it is positive, the project is acceptable. If the answer is a negative, the project cannot be acceptable. So let's move on to the next of the slides, then we can find out. So what is the internal rate of return? I'm not going into this because it's a self-correction problem, and it actually stipulates the method, and the internal rate of return will be 13.21 years. And in the second part, if we find out the payback, what is the rate of return is 10%. So if the rate of return is 10%, NPV will become positive, the project now acceptable. And payback period, if you want to find out the payback period, we can find out this payback period. In total, this payback period, we can find out this, we have to go for understanding this payback period. We need to find out this, we have years and the cash flows. So in the second year, first year we not have any positive cash flows. So in the second year, we will be getting 250,000. 300,000. 350,000. 400,000 and 400,000. So these are the cash flows. This is the answer, last part of the questions, payback period. So total money of that we need to invest 700,000 in the first year, and then 100,000 in the second year. 1.7 million in total. If we combine together, this 1.7 million, I didn't write the next cash flows that we have 7, 8, 9, 10. I didn't use them because the payback period is 6 years. So in 6 years, we will be able to recover this 1.7 million. So I'll move on to the next slides. Yes. In the next question, so we need to find out this problem. We have two proposals, which we have the following characteristics, and we need to find out that payback period and the present value. We need to find out the present value. Two things that we need to find out of this question, and I'm trying to solve this, that how we can get these answers. So we have two projects, project A, 1, 2, and 3. So I can put this line 1, 2, 3. And the cash flow that we have, is 5,000. Net cash flow, we need to see 3,000, 5,000, 5,000, 8,000. If you look at the question in part project A, we have initially invested 900,000. In part B, we initially invested 12,000 rupees. So you need to remind us, I'm just trying to write, and we can find out that what will be the answer that we'll be getting. We need to find out NPV, we need to find out profitability index, we need to find out the payback period, and I have written all the values. So we can solve, and we can find out the answers of both the projects. So this is, I'm just trying to cumulate the project 1, 2, 3. Project A, this is 5,000. This right here, the project A and project B. We have two projects, so we need to find out their payback period first. So we need to cumulate the cash flows. We can cumulate 5,000, 9,000, and 12,000. And then we need to cumulate is 5,000, 10,000, and 18,000. So this is the answer that we have. In the first project, we actually invested 9,000. We invested in 15,000. So if you look at this 9,000 we have achieved. So the payback period of the project A is 2 years, whereas the payback period, we actually invest in project B 12,000 rupees. So actually 12,000 is falling in between 2 to 3 years. So the answer is 2 plus something that actually falling in between. So we discussed that payback period is equal to 2 years plus 12,000. 12,000 minus 10,000, 2,000 divided by the cash flow that we have in the current year. So we can divide and we will be getting the answer. So I write here 2 years plus 12,000 minus 10,000 divided by 18,000. So it gives you 2.25 years. So it will give you 2.25 years. So this is the answer that we have. So I explained it that actually in falling, the answer is falling in between 2 years, 12,000 minus 10,000, the cash flow that we have in the current year. So it will, the payback period of the second. So if we compare these two projects, ignoring this fact, what would be their cash flows? Because we have to ignore, we only consider this fact that in how many years we will be able to recover initial investment. So less of the time period, the acceptability of the project is high. So the payback period is less than this project. So we can go for this project. And next is that we need to find out the NPV, and we will be finding out this NPV. If you go for this NPV, one project I'm trying to find out here, NPV is 5,000. We know that the rate of return is 15%. If you go for this, NPV is equal to, we need to discount in the cash flow that we have in the first, second, third year minus initial capital outlay. The answer is in positive, but the project can be acceptable because we have two projects, and in two projects we have to select one project. If we go for the project B, the NPV is 1,394. The NPV of the project B is higher than project A, so we need to go for the project B. So likewise, the profitability index is also, I'm just trying to go for one and 5,000. $1.039. So I put the values to calculate this profitability index. Discounted value of cash flows divided by initial investment. So the answer is 1.039. If the answer is more than 1, the project is giving you positive return. So if we take this one, the project will give you 3.9% return. So in the second project, I calculated, and this answer is 1.116. So the answer is more than project A. So we need to go for the project B. And in this presentation, I have a last question to solve. Is we have two projects. Now again, we have two projects, and now the question is that we need to solve these projects. We have two projects. First project is giving you cash flows every year. A project will give you only 6,000 at the end of fourth year. So in between we have nothing. So if we discounted, we discounted only 6,000 rupees. So the question is that we need to find out the internal rate of return. I don't want to go in details. You have the manual, you have the answers. So if you go, the project A is giving you, I'm just trying to write here, the project A will give you NPV of 34.9.0%, and project B is giving you 13.61% return. So these are the two projects that we have. The answer is 34.9, and the answer is 31.61. So we are just trying to calculate here. We are not mentioning here that which project is acceptable, so we need only calculate this. Determine the NPV for each project discount rate of 0, 1, 5, 10. So NPV we need to find out with an assumption that we need to discount all the cash flows with 0%, 5, 10%. So here I'm trying to calculate the V part, required return. And if NPV 0%, 5%, 10%, 20%, 30%, and 35%. NPV of project A, project B, 2000, 1546. So here I'm trying to find out, I'm trying to plot the diagrams here. NPV is 4,000, 2,000. Here we are trying to percentage, that is a discount rate or return. We have 5%, 10%, 15%, 35%, 40%. So if you look at this, and if you look at this, and this is a point that we have. If you look at this, I'm trying to draw a project here. You can draw it. The NPV basis, and the project is actually having more. So these are the points that we can intersect on the project. So you can say this is the discount rate where both the project having same NPV. But the question is overall we can calculate this, and we actually plot a graph, and we can find out that. But the last point is that which project would you select? What assumptions are inherent in your decision? So the superior project will be one having the highest NPV at the required rate of return. The NPV, we know that the project A is having, project B is having the highest rate of return. If we talk about the zero return, NPV would be higher. So below about 28%. So the point of intersection B dominate at about 28%. So this is the point which actually dominates. This is a point that actually dominates, and then point 28% B below about 28% B dominate, and about 28% above A dominate. We are assuming that the required return is the same for each project, and there's no capital question. For your patience and listening. Thank you very much.